Hello, my name is Richard Conz, and I'm the Chief Technical Officer at Taronis Fuels. I'm here in sunny, beautiful Ankara, Turkey, with our 50 kilowatt mobile gasification unit that we developed in the United States. This system was developed for us to do testing on feedstock, software development, and is really an engineering unit. Was started out as an engineering unit, has now become a capable system of producing gas and demonstrating our capability. So the government of Turkey asked us to bring this system out to show the capabilities of our plasma arc and our patented system. Over here is where the plasma arc is located. It is located in this little vessel back behind the motor here you see on front. Within that vessel are two electrodes. We have the cathode, which is sitting on top and runs up through the top of the vessel, and the anode on the bottom. Basically, we form the arc inside of the venturi between these two electrodes. Now, how the gas is made is that we pass feedstock past that arc. Once the feedstock goes past that arc in a very high heat area, we basically create gas, and that is from a pyrolysis process, and in addition to that, exposure to high electric field. It basically breaks down the components of the ethanol into primary components, and they recombine into gases after it passes through. So once it goes past the arc, we have both gas and feedstock, and in the vessel right behind the very first vessel is what we call our separator. That separator basically takes and will separate the feedstock from the gas. In addition to that, we go into one more vessel, which we call the baffle. That baffle then is like a condensator, which allows liquid hydrocarbons and water to drop out. To ensure that we get liquid hydrocarbons and water to drop out of our gas, we then run the gas through a chiller. That chiller has an input temperature of 15 degrees Fahrenheit, and as the gas comes out and into it, we basically drop the temperature of that gas to 40 degrees Fahrenheit. From there, we basically go into a buffer tank. After the buffer tank, we run through two particulate filters, a 10 micron particulate filter followed by a 1 micron particulate filter. Behind this tank here, which is our compressor supply tank, we have two coalescing filters. We have a 0.1 micron and a 0.01 micron to take out any residual liquids at that point. We run through a back pressure regulator, which we hold 15 psi of pressure in the gasification and in the filtering system back to the arc. And we come through a cutoff valve, through a regulator, and into this compressor. This compressor will compress the gas up to 1500 psi, which is our final pressure in our cylinders out back here. And prior to going to those cylinders, however, we run through another set of filters, coalescing filters, to take any oil that may have seeped through during the compression cycle. This is the very first cylinder that we're making gas into in Turkey. In these two drums here is our feedstock. The feedstock that we use is ethanol, and it's a recycled ethanol from a company called Catalent. We purchased that ethanol from them and basically use it as our feedstock to create our gas. So here is the barrel that we're currently hooked up to. We basically will pump out of this barrel through a diaphragm pump, and from that diaphragm pump, it will go into the heat exchanger where the feedstock is actually cooled once it passes through the plasma arc. We have a single rotary lobe pump that is in the system, and basically constantly recycling that feedstock through the arc, chilling it, and then back through the arc again. Also on this side, you get a much better look at this vessel right here, which is our heat exchanger on the gas. What that allows us to do is take out any water or liquid hydrocarbons that are in the gas at that point. We had to bring a generator with us. So we actually have a 450 kilowatt generator that we brought from the States to power the system up. And also here you can see that that is our cooling tower. That cooling tower actually runs these lines here through the cooling tower, which then goes through this heat exchanger and cools our feedstock. So a few other components of our system I would like to show you. This item down here is our power supply. It's a standard off-the-shelf welder. This power supply is capable of 50 kilowatts and hence our 50 kilowatt system. We typically don't run this at 50 kilowatts. We'll run it somewhere around 35, 40 kilowatts in that area. But that is our power supply for the system. And on there you can basically see the voltage and the current that is currently being supplied to our plasma arc. This box that you see to the far right is actually our control box. In there we have two PLCs. One PLC basically talks to the man-machine interface here that is on a laptop computer, and the other PLC basically takes all the input and controls from the system and controls the arc. And then one last item here on this skid is our compressor controller, and that basically is the control capabilities for our compressor. And then finally, one last item that we'd like to show you is our chiller. That chiller back there is currently running at 15 degrees Fahrenheit and basically taking propylene glycol through the system and chilling down the gas to 40 degrees Fahrenheit. Now I'd like to introduce you to Chris. Chris is one of our operators and engineers at Taronis Fuels, and Chris is going to take you through the startup procedure of this system.
Hello, I'm Chris Carey. I'm an electrical engineer with Taronis Fuels, and I'm going to show you the 50 kilowatt mobile unit that we have out here in Ankara, Turkey. Currently, we already have it running. It's going pretty strong. That's why you see a lot of green lights everywhere. And I'll run you through a few things that you'll see on the screen. Up here in the top, you'll see our arc time. So this registers how much the arc is actually present. Lets us know how many hours we're actually putting in work and making gas off of that. And then we'll split off into our small subsystems. So we'll start at the top left with our power subsystem. This is showing our welder, and it'll register the voltage, the amperage, and then the kilowatt that this welder is putting out to the arc. We'll do a little side shift to our feedstock subsystem, and this will register if the feedstock tank needs to be refilled, and automatically it will continue to refill our system as it requires more feedstock. Then we'll move to our Venturi. Now this is where all of the work is really done. On the screen we have our plasma arc Venturi vessel, and that's where the welder is attached. So inside there, our electrodes are actually creating the arc, and that's where all the gas is coming from. Then from there, it moves into our separator vessel. At that point, you'll separate the gas from the liquid, and the gas will go up out into our baffle tower, and the liquid will come down to get reused back into the system to get another pass through by the arc to create even more gas. From there, the gas travels into our cooling subsystem. Now this subsystem split into two parts. We have the chiller and the cooling tower. The chiller is what's going to chill the gas to a very low temp, remove any condensates that could be in the gas. The other part of the cooling subsystem is the cooling tower. Now what that is doing is cooling off the feedstock so that it stays at a temperature that we like for our arc. Nothing will get too hot, it stays right in the spot where we like it. Out of the cooling subsystem, the gas makes its pathway into our gas subsystem, and this is where we store a little bit of gas to try and create a buffer and we also filter our gas at this low pressure right here. And then from there we get our final subsystem, which is the compression, and there it goes into our compressor. From the compressor it goes through our high pressure filters, and from there directly into our bottle. And at that point we are filling a cylinder. Everything's still green, and at this point we're just going to let it keep running and keep making gas. Thanks for joining me.
So in short, this is our system. It's here in Ankara. We are filling our very first cylinder, and we're happy to have you along and happy to be here.